Okay, hi everyone. Today we're going to solve this problem that is the LeetCode 90 subsets 2. It's a medium problem and it's a very famous popular problem. Let's see. So we are given an integer array nums that may contains duplicate. Okay, there can be some duplicate elements in the integer array nums. Return all the possible subsets, the power set. The solution set must not contain duplicate subsets. So it should not contain any duplicate subsets, and I will tell you why. What does that mean? So return the solution in any order. Fine. So we have this 1 2 2, and these are the this is the power set where we don't have any duplicate elements. Let's see what do they mean by this. So we have 1 2 2, and now I'm not going to generate a power set without duplicates. I'm going to generate a power set which may or may not, which I think most probably it will have duplicates, right? And the algorithm for that is either we will take that element or we will not take that element. And if we take that element, so for example we are on this subset, if we take that element it's going to be 1, right? And now I'm going to solve for plus, I'm going to solve for 2 comma 2. And if we take, and now I'm going to solve this because it's a DFS calls obviously, so I'm going to solve in a depth first fashion. So 1, and now I'm going to solve for this. If we take 2, so it's going to be 1 2. Now I'm going to solve for the remaining part, that is 2, and now I'm going to solve for 1 2 2, and the string is empty, and I will call it quits. And this is the base condition where my index or the string is now exhausted, and this is one subset that I have obtained. So here I will write these subsets. So now I have obtained one subset, that is 1 2 2. Fine. I will backtrack to this and I will say, okay, I won't take 2 this time. So if I don't take 2, it will be 1 2. Okay, it will be 1 2. Now this s of 2 function calls are exhausted, and we are done with the execution of this function, and now we can backtrack to it, and we will say that this time I will not take 2. Previously we had taken this 2, but this time I will not take 2. So what we are doing is we are calling this function, and initially it was an empty temporary or subset container, and we're making some decision that either we want to take this element or we don't want to take this element, right? And the leaf nodes are going to be the elements of that power set, not subset. So now we don't take 2. If we don't take 2, it will be 1 only, and we're going to call recursively for 2. And we again have two options, either we're going to take 2 or we are not going to take 2. So if we take this 2, it's going to be 1 comma 2. Okay, we can write this here because this is a leaf node, 1 2. And then if we don't take 2, it's going to be 1 only. So we will say 1 only. And now this s of 2 function is exhausted, and now we will backtrack to it, and s of 2 comma 2 function is also exhausted, and s of 2 comma 2 function is also exhausted. So we will backtrack to this part, and we will say that, okay, so now if I let's say now if I take now we will talk about this part. Either I'm going to take we were talking about 1 initially, right? Either we're going to take 1 or not. And now I will say that I'm not going to take 1. So because we have taken 1 in the initial calls, but now I will say I'm not going to take. So I'm going to erase this part because I hope that you all have taken an understanding of what was going on in this subtree. But now we are not going to take 2. So we are going to say, okay, this is an empty subarray, and we are going to solve this for remaining part, that is this one, s of 2 comma 2. And now I will say I will take 2. Fine, it will be 2. This is going to be s of 2. And then I will say, okay, fine, I will take 2 again. This will be 2 comma 2. So the subset is, because this is a leaf node, we're going to say, okay, the subset is s of the element is s of 2 comma 2. Now I will say I don't want to take this 2. So if I say that I don't want to take this 2, I will end up with 2 singleton. And then I will backtrack to it because 2 calls were made, and these were only the calls because we are either taking or not taking it. And now a function has done both of its call, so it can backtrack to it, signifying that the function has made all the calls necessary for the termination of that function, and this function is terminated, and we're backtracking it to it, and we'll say we will not take 2 this time. So if I say we don't take 2, the empty array is going to be empty because we haven't taken any element from the string, and we're going to solve recursively for the other part. And this other part is going to be having two calls again, either take or not take. And if we take two, it's going to be 2, and this is a leaf node, so we're going to store it. And if we, this is a leaf node, we're going to store this. And in this part where we are not taking 2, we will say okay, if we are not taking 2, then it's going to be an empty, which also means 5, in mathematical form. And then we are going to end up with this part. So now this function is done, we're going to backtrack to this function is done, we're going to backtrack to this, and this function is done. So now our calls are made, everything is done, and now we will be left with these elements. So how many elements are there? There are 8 elements. So for s of string which has the size of 3, the power set size is going to be 2 raised to the power 3, right? Including the empty element, or the 5 element, null element of, we say. But in this case you can easily identify there are duplicates, 1 comma 2, 1 2 and 1 2. This element is same, exactly same. Why we are storing it? This element is same, why we are storing it? We don't want that, right? So because of this condition that we don't want duplicate elements into our power set, into the output that we want to generate, we're going to modify this algorithm. Let's see how we can modify this. Just for the sake of simplicity, I'm going to take this again, this example again. So I will call solve for this 1 comma 2, and this is an empty array, the subset. So before making a recursive call, I will store the elements, I will store the power set generated. So I will say, okay, this is in my answer, so this is like my answer space, and I will say empty set is stored here, because before making a call we are going to store that element into the power set, or the required output. And I'm going to call it again recursively, but this time we have to be very careful. We are not going to store the leaf nodes, because leaf nodes are very much dependent on the fact either we are going to take it or not going to take it, right? And there is a high chance of having duplicate elements when we are following the algorithm which is going to include the leaf node element concept. So we are not going to use it, but we are going to use it. We're going to store the subset before making a recursive call. So in this case, I will say I am on this character 1. I'm running a for loop, and I will say that I'm on first character, and I will store it. Fine, I will store it, and I will call recursively for this string, and then this 1 should be stored in here, right? And then I will recursively call for s2 comma 2, and for this part I will say okay, we have 1, I will store it again 2, and we are going to recursively call for, and I'm on this character, and we are going to recursively call for s of 2, and we are on this character, and we are going to recursively call for s. So this is, we are going to store this, and 1 2, and for here we have 1 2 2, and now yeah, so we have stored this, right? But the string that we are going to recursively, the function that we are going to recursively call for the remaining string is not going to be called, because there is no remaining string. So this is our leaf node, and we will say okay, this is the and it will end up in a base condition where we don't have a string, or where we have the index out of the string. So we will store this part as well into our into our answer. Sorry. Now when the string has done its, so now it will backtrack to this parent function, and the iterator will now point on outside, out of the array bounds of the string, out of the index bound of the string, and which means that this function is also completed, has also completed its execution, and now it is terminated. When it is terminated, it will backtrack to the parent function, and in parent function we are going to increment this pointer. So when we increment this pointer, now we have this string 1, and this is actually an invalid call. This shouldn't be made, but I'm just going to give you an example why this is an invalid call and why it shouldn't be made. So we have 1 comma 2, we take this, and there is no other element. Now if you will look closely, this 1 comma 2, what it is, we already have this element, it's a duplicate. So now we realize that if we are going to make another call in a for loop, and the current element is equal to the previous element which is already processed, the current element which by which the addition of by the addition of which we are going to make another elements of the power set is already equal to the previous element that we had. It will generate duplicates. It will generate duplicates. By this observation, I will say, okay, so I was previously at 2, but now I'm at 2 again. So this is an invalid call. I'm going to skip this because it's going to give me duplicates. So I will be out of bounds. So if I'm out of bounds, I will say, okay, I'm done with the execution of this as well, and I will backtrack to my parent function. And when I'm backtracking to it, I will move to another element that is 2, and I will say, okay, so this is an empty string, and I will take 2, and we are going to call for the recursively for the other part that is 2. And in this part, we will call again for this element that is 2, and it will be 2 2. Okay, and we are going to store 2 again, and we're going to store 2 comma 2 again. And now we don't have any remaining string, so this is our leaf node, and we will store it. We will backtrack to this because now the function is complete, and this one, when we backtrack to it, we're going to increment the index, and it's going to point out of the index bounds of the string. So we're going to backtrack to my main function again, and this time I will increment this, and now I can, the observation that I made earlier, that it's going to give me an error, and the error is that 2 is equal to the previous element that is already processed in the same call stack, which shouldn't be the case because it is going to give me duplicates now. How? Because if I will say that, okay, so just for an example, if I will say now I have 2, this 2, we have this 2, we have elements of the power set beginning with 2, but we already have those elements through this call, through the call that is made earlier in the call stack, which is the reason we are not going to call this, and we're going to skip this. So when we skip this, we are out of the bounds, and we say that, okay, we are done with the execution of this, and we are out. Now if you will count elements, there are 6 elements. Fine. And how many elements are there in our answer? There are also 6 elements. And if you will count them, we have an empty, and if you will see, there are no duplicates. So 1 comma 2, which was repeating in the earlier algorithm, earlier process, but it's not repeating again. 2 was repeating, and it is not repeating this time. So this is a good algorithm. We can use this. And one major thing which we need to take care of is the elements need to be sorted. We cannot have this way like 1 2 and 1, for example 2 1 2. In this case, 2, we are going to make subsets of, we are going to make different subset, because in this case we don't have any element that is equal to the previous element, but we needed to skip a 2, but we cannot skip this time, which is why we need the input array that is nums to be sorted. So let's solve this. So first of all, we're going to sort this. So nums dot begin, nums dot end. After sorting it, I will create a vector of vector int my answer, and yeah, another part will be to have a solve function in which we're going to have the nums, then we will have the index from where we are going to start the execution, because in this case we cannot afford to create a new substring again and again for every call, because if we have a large, let's say if we have a large string, it can create memory exceed, or it's not memory wise, it's not optimized, which is why we're going to use an index strategy. And then we have answer, because we want to store elements in our answer, and then I'm going to return my answer. So let's write a private function, member function. It's going to be a void type because we are not returning anything. Then we have solve function, and it's going to be a vector of int reference nums, just for fast transactions. Then we have index, and then we have vector of int answer. That is also an reference, because we want to store different elements from different recursive functions. Now another part would be So we also want a subset, right? We want to keep a track of the elements that we are pushing into our subset. This part, we want to keep a track of these elements. So for that, I will use an int, and it is going to be a temp. It's not a reference, and it's a default parameter. So it's going to be empty if not passed in the main call. Right? It's not passed in the main calls, which means it's empty. And my first thing will be right here, because I'm pushing this array, this temp array, which is the this element of the subset, into my answer. That's what I'm going to do. Push back the temp. Fine. Then I will call int I is equal to 0. So not 0, int I is equal to index, and I has to be less than nums dot size and I plus plus. Now what we will do is we say temp dot pushback, right? So we are pushing the element temp dot pushback, and the element is nums of I, and then we will call solve again, right? We've pushed the element and then we call solve again for nums. The index is now incremented I plus 1. Sorry. And then we have our answer as it is, and temp, because now we need to keep a track of the temp variable that we have, temp array, or the element that we are constructing as an element of the power set, right? And after this is done, I'm going to just pop back the element that I have placed earlier, and I am done with this, right? But there's a condition for duplicate. If I don't want to duplicates in my array, what I will say, if I is not equal to index, right? Because the first element needs to be placed, and we don't have any way of, first element needs to be there in the power set. It needs to be first element needs to be inclusive, let's just say that. Because if we, for first element, we don't have any previous element, right? Because for example, for this string s2 comma 2, we don't have, if we are on this element, we don't have any previous element, which is why it will only work for the index plus 1 elements and so on. And I will say that nums of I is equal to, if it is equal to nums of I minus 1, then it's a problem. In that problem, we need to just continue. We don't need to push that element or solve for that element. We don't want to make any call for that element, right? And yeah, I think that's it. Let's run this code. So this test case is getting done. Let's add another test case. 1 2 2 3 3, and yeah, and then 1 again. It's unsorted. Okay, so I think we are doing fine. Let's submit it and see if it's accepted or not. Okay, it is accepted, and it's a very fast solution as well. So now if we talk about the time complexity of this solution, so let's see this problem. So first of all, we are sorting this element. So the time function is going to be n log n, where n is the size of the nums array. So we are sorting this, and then we are calling this solve function. So how much time do you think it's going to take? It is going to take none other than 2 raised to the power n, because it's a recursive function. It's calling itself again and again, and there's a for loop as well. So it's going to take 2 raised to the power n time. And if we want to have the time complexity, then it's going to be, this is a very small term as compared to 2 raised to the power n, so it will be ignored and it will be big O of 2 raised to the power n. And space complexity will be same, big O of 2 raised to the power n. Why? Because we are using, first of all, call stack. Then we are using a vector, answer vector, which is having elements equal to the 2 raised to power n elements, almost 2 raised to power n elements if there are no duplicates. So this is the question, and I hope it's, I think, kind of clear. Well, anyways, thanks for watching, guys.